Okay, so hi everyone. I'll introduce myself again. Welcome to this webinar organized by DIYguru, and I'm Shivali. I'm from the support team. Okay, so let's give a warm welcome to our speaker, Mr. Ashutosh, and he's a seasoned expert in embedded system for electric vehicles. All right, and with 5 years of experience, he has worked on like cutting edge EV technology. And today he'll unravel how embedded system powered the future of mobility. Okay, so Ashutosh, are you there, right?
Yes, yes, Shivali.
Yeah, okay. So, all right, Ashutosh, now you can take the webinar ahead. Yeah, but yes, I would like to say one thing. We'll drop two forms during this webinar. First is the attendance form that we'll drop in a short while, like in 1 minute. I'm going to drop the attendance form in the chat box and kindly fill the attendance form, and we'll be providing you the certificate of participation. And another form that we will be sharing is the feedback form. We will share it before the Q&A session begins. Once the webinar gets over, Ashutosh will take your question and answers. And once before that begins, we'll share another feedback form. And it is important for us to know like how did you find this experience? Okay. So Ashutosh, you can please take this forward now. Thank you, Ashutosh.
Uh, Thank you, Shivali. Thank you, Jisan. Uh, Very good evening to all, to everyone who has attended this wonderful webinar. My name is Ashutosh Deori. I have done my bachelor's in electronics and telecommunications. I have already worked with Tana Graziano, Softcon. My tech stacks are, I have already worked in maintenance, in project, and from past 3 years, I'm working in embedded system. Now, in DIYguru, my role is to develop embedded system using ARM Cortex chips, you can say. And already I have worked with many microcontrollers, for example. I have already worked with 8 Mega, with PIC, with ARM LPC71768. Already I have worked with Raspberry Pi, Arduino. But right now I'm working with STM32 and NXP. So this is a little bit brief regarding me. So let us start the session. So the today topic is the relevancy of embedded system in EV. So it is one of the very hot topic. And so let us start. So let me share my screen.
It's not visible, sir.
Yes, I know. Now it is visible.
Yes, sir.
Yes. So right now it is a very hot topic, embedded system in EV, and today we will unravel this particular thing. So before starting this, let us see what we are going to see here today. So, so what is the agenda of this particular webinar? So in this webinar, we are going to cover many things. For example, before going to the applications of embedded system electric vehicle, it is very important and imperative for us to know what is an embedded system, what is the significance of embedded system, what are the different types of embedded system which are used in different types of industries, why nowadays embedded system is so popular, and what are the components of microcontroller, what are the different components of an embedded system. And at last, we will see the applications of embedded system electric vehicle. But yes, also, I will give a brief overview of our kit, which is exclusively developed by DIYguru. We have already given application for the patent. The coming days, definitely we will get the opportunity to work on that. Yes. So, yes. So my first, yes. So first of all, it is very, very important to know what is an embedded system. In so an embedded system is a specialized computing system, you can say, yes, and perform dedicated functions. So it can work alone or it can be used along a system, right? So in layman language, if I want to say, you can see that I have a software, piece of code, you can say, yes. Then I have a microcontroller and I have some peripherals or hardware. So in embedded system, what I'm doing, so here I'm controlling the hardware with the help of a microcontroller. But yes, in microcontroller, I'm flashing something, or I can say I'm flashing a code, or I'm flashing a former. So yes, so with the help of a code or a former, I'm controlling the microcontroller, I'm processing something, and as a result, I'm able to control my hardware. So this is a layman language, how we can define embedded system. Yes. So we can say that, yes, it is a specialized computing system that performs some dedicated functions. Yes. Now, first of all, what are the some characteristics we will see? Yes, it has real-time computing capabilities, and in embedded system, it is designed specifically to perform what I will say a dedicated task. So yes, so this we can say that yes, it is designed for real-time computing, and it will perform some uh, task specific design. Okay, so these are some things we can say that right now, which is right now adapted for this embedded system. Now next, what is the significance of embedded system? Yes, nowadays it is used across many systems. So there are mechanical systems, electrical systems. In mechanical system, I can give in the further slides we will see where embedded system is used. In electrical system, one example I can say your traffic light, or I can say traffic signal, all controlled by a microcontroller. Yes. Now, in specialized computing, also we can say that nowadays embedded system is also used in satellite, also is used in supercomputers. In mechanical systems, I can give an example, small example. In robotics arms also, we are using embedded system. So these are some vast uses of embedded systems across many systems, across mechanical or electrical systems. So this is the reasons why it has become very, very important and necessary at this particular time. Yes. Now we will see the applications of embedded systems. So where the embedded systems are used. Yes. I can say that embedded system is omnipresent and it is used everywhere. So starting from your household appliances, for example, yes, in your microwave and in your washing machines, you are using embedded system. Yes. So one specific task you are doing, for example, in microwave, you are heating particular food items. In a washing machines, one specific task you are doing, you are cleaning your clothes, right? So again, so these are some specific tasks is done by this particular items, you can say, this washing machine or microwave. Again, embedded system is also used in consumer electronics. For example, right now, many of us, we are using smartwatch or smartphone. Smartwatch, yes, a specific function that it is doing, it is giving some time, some messages, some other related things are doing. So yes, it is also used in consumer electronics. And also we are using for other things also. But yes, some properties are there. We have convenience in using these particular things. And also we are automating tasks. So we will come across these things when I will explain each part in detail. But yes, now we are seeing the different applications of embedded system. Yes, it is used in household appliances. Nowadays also it is used in fans and all. Fans, AC, coolers also use, we are using embedded system. So yes, we are using across household appliances, across consumer electronics, and many other things we will see. Next. Yes. This is, you can say that we are also using embedded system in very precise manner. Yes, we are using in precise manner, but across other sectors also. For example, in automotive, in healthcare applications, in telecommunications, we are using embedded system. So here I have just given one examples to show you that how precisely for precise actions we are using embedded system. Yes, we can know that everybody we know that in our car, we have airbag. So airbag deployment is there. It is for our safety. So whenever a car collision will appear or accident is happening, so immediately our airbag should open. Yes, so this particular uh, functions comes under embedded system. So for this, a microcontroller is responsible is there. So we are using microcontroller in ECU, and ECU is controlling all these things. Okay. Next, now sometimes many patients heart doesn't work properly. So for that we are using a pacemaker. You can see. So to if you are using artificial pacemakers, we are also using embedded system in that. Next. Yes, we are using routers and many network devices. You can see this in this particular items also we are using embedded system. I will come down and I will show that in embedded system what we are using. I will come down to this point, but before this, we must clear what are the applications of embedded system across different sectors, right? I will come down to this point, why real time. So this point is there, real time. Don't worry, in the upcoming slides, I will explain this, why it is real time. So you can see this, that yes, we are precisely for precisions, for real-time applications, we are using embedded systems. Yes, we can do this particular functions, for example, real-time. Uh, yes, real-time, if you want to use in real time, you can use across different sectors, across automotive, healthcare, and telecommunications. Yes. Now, yes, this is also a buzzword nowadays. What do you mean by IoT? One of the very important thing I will say, it is used across many industries. Also, it is used with Industry 4.0 revolutions, with industrial automations. But yes, it is very, very important to know what do you mean by IoT. IoT means Internet of Things, and we must know what do you mean by IoT. So what is mean by IoT? So the little meaning is here, Internet of Things. So in this particular IoT, what you are doing, let us see this. So here I can write in a small, in just literal terms, I can say that in IoT refers to a refers to a refers to network of interconnected physical devices. Physical devices that, yes, collect, exchange, and process data. I'm not writing here because limited space is there. So you can say this, that IoT means refers to a network of interconnected physical devices that collect, exchange, process data over internet without human interference. Remember this. So here also in IoT also we are using embedded system. So here also we are using microcontroller, microchips. But yes, they have some properties like as they are used in this for this particular purpose, so they must optimize for low power. Low power, that means they can work in low power. Yes, they can be battery operated, and yes, they are connected to internet. So this one thing. So this is a little meaning of IoT. I will take down all the your doubts and your questions after the end of the session. So please bear with me. Let me complete this all these things, and then I will take the doubts. Right. So yes, in IoT also we are using uh, microcontroller, and also we are using embedded system. And yes, we will see in the next. We will see the next thing. Yes. Now, what are the other applications? Let us see this. Yes. Also, we are using embedded system in defense and aerospace. So it is a vast usage of embedded system is there in the defense and aerospace. So yes, for your navigation control, yes, we are using embedded system. For surveillance, for example, if you are using radar, cameras, yes. So you for this also you are using embedded system. Yes. for missile system that deploy missiles or use missiles. Also for this also we are using embedded system. Yes. So we can see that. So embedded system is vastly used in many sectors. So it is also used in IoT, is also used in defense and aerospace, because I will come down to one particular examples in real-time executions. I will just explain that how this particular things is happening, how it is used in this defense, and what you mean by hard real-time solution and soft real-time solution. In that also I will explain something. But yes, now you can see that where embedded system is used. So you can see this that yes, it is used across many sectors, from starting from consumers to defense, aerospace, IoT and all. Okay. Yes. Also, we are using embedded system in automations also. Okay. For example, in industry. Nowadays, we have Industry 4.0 revolutions. In this also, we are using embedded system, IoT, many things. So where it is used, for example, yes, in our robotics arms, we are using in PLC. PLC, we are using microcontroller now. So previously we basically we use a processor for this PLC, but nowadays the PLC are moving to microcontroller based. Okay, so we can say that we are getting PLC which are microcontroller based. Yes, we are integrating sensors. So we will also see how to integrate sensor and all during this. So yes, so in manufacturing system or in, I will say, in industrial automations, we are using embedded system to improve efficiency and precision. Now, yes, now the major question arises that why nowadays why embedded system is a buzzword, and why nowadays we will see that within 5 to 10 8 years it has been popular here. Okay, so why it is popular and why it is gaining popularity also we'll see. Because earlier the maximum systems were based on microprocessor. You can see this. Yes, you can see this. Earlier the systems are microprocessor based. So in that systems we have speed limitations. They were large in size and it was not easy to work on, or you can say complex in size. So to work on this, they were not easy. Now, but slowly we can see this. Nowadays we are moving to microcontroller based system. So in microcontroller based system, what are the advantages we are getting? Yes, it has enhanced speeds. It is small size as compared to this particular microprocessor based systems. The systems which are adopting in microcontroller are small. Yes, and also they have simplified designs. Now, one of the example here you can say, earlier we use one of the example I'm giving earlier in
इसको
PLC.
में सर बीच बीच में आवाज डब हो जा रही है, क्या प्रॉब्लम है? नेटवर्क प्रॉब्लम है, एनीथिंग?
Again, pardon?
आवाज जो है वॉल्यूम वो डिस्कनेक्ट हो जाती है बीच बीच में.
Okay, sometimes it disconnected.
वॉल्यूम.
Value?
या
नो सर, उनका नेटवर्क का प्रॉब्लम होगा, इसलिए उनका नहीं आवाज आ रहा है.
Thanks.
यहाँ पे जो सर आप जो बोलते हैं ना, वहाँ पे वाइब्रेट होता रहता है, जैसे रुक जाता है तो यहाँ भी रुक जाता है सिस्टम.
Okay, any other student facing this problem, or only he's getting that?
No, sir. You are
Okay. So whoever has raised this point, okay, please check your network. Okay, noise. Okay.
हर बार होता है इसमें.
Yes. Yes. So my microcontroller based systems are more efficient as compared to microprocessor based systems. And the point is also, I will explain that why we are using microcontroller. Yes. So if you are using microcontroller, what are the advantages? Now in the upcoming slides, I will explain this. So for all these reasons, nowadays we are adopting microcontroller based system, right? So yes, it has enhanced speed, smaller size, simplified design. So these particular things we can adopt if we are moving for microcontroller based systems, right? One example I'm giving, earlier in PLC we are using we were using a microprocessor, right? But nowadays in PLC, we are using microcontroller. One of the example is Arduino Opta. Arduino Opta.
Sir, what is PLC? If I don't know what is PLC, then how can
Okay, don't
we-
worry. Don't worry. If you don't know PLC, don't worry. Okay, I will take your doubts at the end of the session. Whoever has asked this, okay, don't worry. Who has asked this question?
Sir Sudhanshu Kumar?
Okay, Sudhanshu. Don't worry. Okay, at the end of the session, you just write down and note down your doubts and the slides number, and I will explain those. What do you mean by PLC and all? Okay. Yes, somebody has written that programmable logic control. Okay. Okay, so it is better if I will, because many slides are there, otherwise I will not be able to complete the whole things, right? So it is better, let me complete this, let me finish this, and I will take your rest down. Yes. Okay, just for the time being, yes, PLC means programmable logic controller, you can see. Okay, so in PLC earlier we have used your microprocessor, but nowadays we are using microcontroller. So slowly we are moving from microprocessor to microcontroller. So yes, microprocessor based systems are expensive, but microcontroller based systems are relatively cheaper. Okay, so that's why many things are there for which we are moving from microprocessor based to microcontroller. Okay, next. Yes, now main thing comes here. What do you mean by microcontroller? Yes, so what is a microcontroller? So first of all, we must know what is a microcontroller, then we must explore the other things, right? So microcontroller is a single, you can say a single entity, or I can say single chip with memories and all input output peripherals on it. Okay, just you can see this. Yes, it is a single chip computer. We can say that a single chip computer which has many things. For example, yes, it has input output pins. Let me write here. Okay, input output pins. So with these pins we can connect to peripherals, external peripherals. Yes, also many things are inbuilt here in microcontroller. Remember this, in microcontroller we have ALU is there, and also memory is there. Let me break this down. So yes, so I can say that microcontroller is a single entity where it comprises of CPU, all in that particular chip. Remember this, we have RAM, we have RAM means, okay, random access memory, ROM means read only memory. I hope you know all these things, ROM. And then we have timers and input output ports, which I have written here, okay, pins. So these all things we can get in one just single entity. Remember this. But if we'll compare with a microprocessor, in microprocessor we have only one CPU and other peripherals I have to add. But whereas in a microcontroller is a single entity, or I can say single chip, where these particular peripherals are already inbuilt there. Remember this. So one of the basic difference between microcontroller and microprocessor is this. Yes. Now let us see. So we have now understood what is a microcontroller. Now let us understood what are the components of microcontroller. Okay, it is very, very important. So yes, I have arithmetic and logic unit. So I have ALE unit, which I've already said. So this is responsible for performing, I can say, calculation or mathematical operations. I can say, yes, mathematical operations. Okay, yes. And program memory, yes, so I have different types of memory, but yes, program memory is there. One of the program memory. Memory used to store microcontroller operating program. Remember this. So here you can say it has already program memory and then EEPROM. What is EEPROM? Non-volatile memory for storing data that must be written when power is off. That means whenever power is off, if you want that our data should be there, it is stored in EEPROM. Remember this. Okay. Why RAM is used? It is used for temporary storage of variable and special function registers. You can see this. Already these things are written. I hope you will not get any doubt in this. Okay. So already these things are already inbuilt is there. Inbuilt we are getting in this particular entity in microcontroller. I have ALU, program memory, EEPROM, RAM, input output ports. Yes. So these things are there in my microcontroller. These are components of microcontroller. Again, some next components. What are the other components of microcontroller? You can see. So we have timers and counters. Yes. So why we are using timers? If you want to generate any delay, let me write here why we use timers and counters. If you want to generate delay, I can use timers. Also, if I want to count any event, yes, then I can use counters. Yes. Now another important, what I will say, component which is used in microcontroller is ADC converter. It is very, very essential. ADC module, I can say. This is used for sensors. For example, if you want to take sensors data, for example, temperature, humidity, and all. So here for this particular thing, if you want to take the data from environment or for any other thing, so here I can use sensor. So to implement sensor, I have to use this particular thing, ADC to ADC module, or I can say analog to digital conversion. You can see here. Okay, so with this particular module, I can do this particular functions. Okay, analog to digital conversion. Yes. Now I have here instruction decoder. You can see. Okay, and then serial communication port. So these are some, what I will say, components of microcontrollers. So the basic components we have ALE unit, program memory, EEPROM, RAM, IO ports, and yes, also we have serial communication port also. This also I will cover when we will come down to this one, to the communication protocols. I will cover what do you mean by this serial communications, what we are using, what are the different types of protocols we are using. Yes, so we are using this particular thing. So this particular things also I will explain. So what are the other components? Timers, counter, ADC module, instruction decoder, serial communication port. These things we are using, right? Now, next. Yes, now we will see what is the architecture of embedded system. One of the very, very important. So here we have already seen that in an embedded system, we have, in layman language, I have already seen, I have a software and I have a hardware. Now, to control this hardware, I need a microcontroller here. So first particular, with the help of this code, I'm writing a code here, and this particular code I'm flashing in one particular microcontroller, and this microcontroller is then controlling a hardware. So this is a hardware. Hardware can be anything. It can be LED, it can be motor, it can be battery pack, it can be anything. LED, it can be LCD, it can be a sensor, it can be motor, it can be anything. Okay, so let us see what are the different layered structure of embedded system. Yes, so first of all, I have a firmware in the form of a code. Okay, let me write here. Here, this is my, yes, in the form of code. Yes, then here, so particular, this is a firmware code. I can say, or this is a normal code. So this particular code is stored in particular memory. This particular memory is there in the central processing unit, CPU. And yes, so after this, we are controlling, for example, with the help of input output pins, I'm controlling a hardware. Okay. So, okay, I'm not going to that particular hardware, just I have the hardware. So if I'm just considering this particular embedded system, or I will say not embedded system, it's just only microcontroller. So in microcontroller, I have a firmware. This is my memory. So my firmware is there in the memory, and memory is there in my central processing unit. And yes, so in the central processing unit is there in my hardware. Okay. So when I will explain this 8-bit and 32-bit microcontroller, it will be more easy to visualize. Okay. So what I'm saying here. So I have a firmware, memory, and then CPU, and then I have a hardware. So this is the architecture of this particular embedded system. So let us move. Let us see one by one. So every embedded system consists of a built hardware, okay, built around a central processing unit. So this is our central processing unit, you can say. So this hardware also contains memory chips onto this. Okay, yes, memory chips, this one. So the software residing on the memory chips is called firmware. You can see, yes, firmware, or you can say that it's code. And yes, then either we are running an operating system over this, or sometimes we are not using operating system. The same thing has been written. So here we are using operating system, or we are not. It is not compulsory to use an operating system in every embedded system. Remember this. Okay. So this is something regarding firmware, memory, and then CPU, and then hardware. Okay. Let us see this now. Yes. Now let us see this in a little bit. What I will say in an enlarged view. Now we have various building blocks of this embedded system. Now we will see the components of embedded system, right? So in component of embedded system, we have different things. For example, you can see now. So this is my output devices, and I can connect my embedded system to get any output. For example, I can get my output from display or speakers. What are the memory which are associated with this particular embedded system? I have ROM, I have RAM. Okay, and then I have, for example, yes, flash memory. Yes, flash. Okay, what type of either we are using microcontrollers. Here you can see this, and also what are the components here? Other components we have, for example, yes, we have a central processing unit and input devices. What are the input devices we are giving? Means, or we are using sensors, keyboards, and yes, what are the communication protocols or interfaces we are using? Here we are using Wi-Fi and Bluetooth. So this is the components of a embedded system. So first of all, if you'll see the building blocks here, I can say, first of all, I will say input devices, then output devices. I have central processing unit. Memory will be there, either in the form of RAM, ROM, or flash. Communication interfaces will be there, and then some application-specific circuitry. So this is the components of embedded system we have. Okay. Yes. Now we will see what are the properties of embedded system. Yes. First of all, our embedded system should be reliable, very much reliable. It should 101% reliable. Because if, for example, if we are using embedded system in our pacemaker, and if my pacemaker is not working, then that person will die. Again, second example, if I am using embedded system in, for example, for my airbag operation, and at one particular situation when accident is happening or any collision is happening, and my airbag is not opening, that means my embedded system is not reliable. So yes, so first of all, what are the properties of embedded system? Yes, it should be reliable, 100% should be reliable. It should execute specific task. For example, if I'm dedicated one particular microcontroller or one particular ECU, I can say electronic control unit. In one electronic control unit, I have, let me write here. So I have ECU. In my ECU, I have a microcontroller. This microcontroller, I can say this ECU responsible for airbag operation. Yes. So first of all, it should be reliable, 101%. Yes. Second, what is the specific task? So whenever any collision or accident happens, then immediately it should open. So this is the task of this particular ECU, I can say. Okay. Yes. And what are the other functions, other properties of embedded system? Resource constant. Yes. Because in a microcontroller, I have my memory is defined. I cannot increase the memory of microcontroller. So for this particular situation, I will say that yes, I have resource constant. I cannot make a code which is beyond this particular capacity of this particular microcontroller. Okay. Yes. And so that means in related to the memory, I have resource constant is there. Yes. In related to task, it should work for specific task. It should be reliable. And third, it should meet 101% deadlines. So this is very, very important. So whenever the collision or accident happens, within, I will say microseconds, I will not say milliseconds, within microseconds, the airbag must be open. Otherwise, it will not be called as a reliable embedded system, right? So these are some specific, I will say, properties of a embedded system. It should be reliable. It will perform specific tasks. Yes, it has some resource constant is there. And in terms of memory and storage, many other things also we'll see in the upcoming slides. And yes, it should meet the deadline. Okay, means it should meet the strict, means at a particular, what I will say, in one particular timeline, it should adhere to the timeline, right? That's why we are saying that, okay, deadlines adherence should be there. So these are some properties I can say for a embedded system be reliable. Okay, reliable, specific task, resource constant is there in terms of memory, and yes, and it is adhering to the deadline. Next, yes. Now the same thing has been written a little bit in a enlarged view, that yes, also we have constant in terms of what? Yes, power consumption. For example, in a microcontroller, we are dealing with 3.3 volt and 5 volt. So we cannot go beyond that particular voltage. So yes, we have power constant regarding that. Yes, embedded system used in extreme environmental conditions. For example, if you're using embedded system in satellite, yes, in satellite, okay, yes, that in whenever you're using embedded system in satellite, we know that, okay, in outer space, the conditions are very harsh, or I will say very, very difficult. So our embedded systems should be so reliable that even if we have a harsh condition or extreme condition in terms of temperature or humidity, it should work on that, right? So that we can say that, yes, our embedded system is reliable and it will give the correct figure or correct data or anything for what purpose we have built that embedded system. They can provide that particular, functions, right? So yes, so my embedded systems has properties to work on extreme environmental conditions. Yes, it has power constraints also, as they are sometimes operated by batteries, and also they have operated by batteries. They cannot be operated by other means. And basically in embedded system, we work with 3 volt and 5 volt. So yes, there are some power constraints is there. And yes, again, it should be reliable. It should be 101% reliable. So these are some properties of a embedded systems. So let us see. Yes, it should be cost effective. Embedded system should be cost effective. So here we have example of one particular toys. So in a toys, we cannot increase the toy, for example, to 20 rupees or 30 rupees or 50 rupees. So yes, our embedded system, whenever you are using embedded in one particular system, it should be cost effective, right? Next. Yes. Now we will see what are the classification of embedded system as per the applications. So this is very, very important. Okay. Yes. As per applications, we have standalone embedded system. I will come down. Don't worry. So standalone embedded system. I have real-time embedded system, network information appliances. I will come down. What do you mean by this network information appliances and this mobile devices? I will not cover one or two. I will cover here, and we will see on basis of applications how they are classified. So we can see this. Yes, in standalone system, they operate independently without other connections, or they have the capability to work independently, right? But in real-time system, yes, I will come down. What do you mean by real-time system? Real-time system means it must have some time limitation is there, and yes, if response is there, input is there, you have to respond as per that. For example, here I can give that, I can say pacemaker and this one, pacemaker and airbag operation. Yes, they work in real-time system. Yes. So in this particular usage also, we are using RTOS, real-time operating system. So I will come down, no worry. I will explain that with the help of an example, so it will be clear for you, right? Yes, then I have a network appliances. Then this also I will explain what do you mean by this network appliances. So we'll see one by one here. So first of all, what are the components of standalone system? So these are some examples of standalone system you can see. So here, yes, I have one microwave, or I can say I have this particular washing machine. It is not connected to anywhere. It is just a washing machine. Okay. So these are some So what are the components of this? We have inputs. For example, we have given some inputs in terms of switches. So by pressing buttons, we have given some inputs, and we want to perform some actions in washing machine where we are processing those things and we are getting that particular output. That we can visualize in a microwave oven also we can visualize in this particular washing machine also. Okay, so we are giving some inputs. So my particular embedded system, or I can say my device, is performing some task, and then it is giving some output, right? So these we can see some examples of standalone. Now, yes, this is very, very important system. Now, let us see what are the properties here. So first of all, real-time systems. Remember this. We have two types of real-time systems. One is hard real-time system and soft real-time system. Remember this. Hard real-time system means, let me show here. So this is hard real-time system and soft real-time system. Very, very important. Okay. That means hard real-time system means it has to adhere some time limit here. For example, here you can say missile targeting, yes, and valve operation, yes. So for this, I need hard real-time system. Why I am hard real-time system? Because I have some, let me write here. I have some time limitations are there. Yes, in my soft real-time system, limitation is there, but even if there will be any delay, in my timing, a accident will not occur. I will give that example. Here you can see this. Now, so here you can see this. If you are taking a missile here, and for example, we have fixed the target, and we are not able to target our enemy fighter, then if we'll miss the target, then what will happen? The enemy fighter aircraft will destroy ourselves. So remember this, how much precision we need. So all this comes under the hard real-time system. So we have two types of system. One is hard real-time system and another is soft real-time system. So in my hard real-time system, I'm considering those systems which are adhering to the time limit. So the time limit is there, and I have a very strict time limitation is there. But in soft real-time system, time limitation is there. But even if I miss the what I will say, any time, what I will say, time target, still nothing will happen or accident will not happen. Yes. So one of the examples of hard real-time system is this one, missile system, which is integrated in our fighter aircraft. The next one we can see in the soft real-time system. In soft real-time system, yes, we have what are the properties of this particular system. Let us see this. So first of all, I have flexible in deadlines. Okay, the systems can tolerate occasional delay. Remember this, occasional delay, right? Non-critical applications. For non-critical applications, we are using such type of you can use this soft real-time system. Yes, delays can be tolerated, right? So here, for example, in DVD player, yes, in DVD player, for example, you can see even if there will be any delay for milliseconds or microseconds, still it is manageable. Nothing is happening or nothing big is happening or any accident is not happening. But yes, if you are missing any target or if you are missing other examples, for example, in hard real-time system, I have pacemaker. Yes, also I have this, yes, airbag operation, satellite operation, airbag operation. Yes, these meets hard real-time systems. Remember this. So these are examples of hard real-time systems. Okay. So we get a basic difference between what you mean by hard real-time systems and what you mean by soft real-time system. Next. So we have seen this. Now let us understand what is meant by networked information appliances. One of the very important concept. Let us see. Now, a simple word I can see. Yes. Now, it is better to understand with the help of an example here. Yes. Yes. For example, I have a smart lock door lock system. So for example, if someone is working and his or her children has gone to the school, and now, for example, after school, they have come to the home. So as per this particular system, network information system, yes, so it belongs to one type of embedded system. So here, for example, if I'm giving example here, the children approach to the door. So in my house, for example, let for anyone, XYZ, okay. In his house, it's his children or his children's approach to the room or to the house. And then in that house, we have already a camera is installed there. So that camera detects the presence of that particular person. Or also you can, nowadays we have that camera that we can detect the who is the member of the family who has arrived now. Okay. Now this will send an alert to whom? It will send an alert to the parents, the mom or dad. Okay. Now from there, with the help of their what I will say, laptop or the help of their mobiles, they can see that who has approached their door of the house, and then they can give a access that yes, our children has arrived to the to our home. Then I can give a access here. Then mom and dad can allow that particular access. Okay, then that children can directly go to the home. So here we don't need other interfaces. So this is one of the example of network information system. So this in network information system, many examples can be, I can say, smart refrigerator, okay, network printer scanners, industrial IoT sensors, I can say, smart energy meters. So let me write here. So yes, what are the other examples? Okay, I can give in this particular thing. So here I can say that I can smart refrigerator. I can control the refrigerator, operation of a refrigerator from a remote location. Then I have smart energy meter. And then I have, yes, industrial IoT sensor. Yes, so these are some examples of network information system. Okay, network information appliances. So here also, first of all, actually in this, what is happening in this particular thing? Let us find out. Okay, so first of all, embedded system connection is there, it's connected to the network. Remember this. So first of all, and then if I want, for example, if I want to send some data, which type of data? For example, I have a temperature or humidity sensor is there in an environment, and I want to send the data. Yes, I can send the data. So I have a system of, for example, I have 3 places. From 3 places, I'm collecting the data and I'm transmitting the data. You can see transmitting the data. And then on one particular situation, I'm just monitoring those data also. Okay, with the help of monitors or LCD or graphical LCD or OLED. Yes. And also, for example, here, at some point of time, I need some camera. Okay, I can use camera. Okay, for example, if I at some functions I need camera, I can use that. Yes, I can use the data or image, and then I can push that that particular thing for HTTP server operation. So these are some, what I will say, steps for the network system operations. One of the other example I can say, in smart city we are using, this is another example, we are using, yes, cameras for surveillance. So in smart city we are using camera for surveillance. Okay, so this is the best example of network information appliances where cameras are connected to the internet, and yes, the output of the end user with the help of this HTTP, HTTP means it is connected to the World Wide Web. Okay, www. Okay, triple. Okay, so for that we can able to access any page, and with the help of the page we can see all these things, what is happening in particular locality. Okay, so this we can consider that come under network information appliances. So one of the best example is usage of camera in a city. So these are some examples, and also I have given so how we are using this particular, yes, for also smart door system, how we are using this particular in this particular network information system, that also I have explained. Next, what are the languages which are using in embedded system? Very, very important. So yes, we have C and C++, So for right now, I'm saying that, okay, we restricted to this. And yes, also we are using ADA and all, but nowadays, maximum we are using C, C++. Yes, you can see this. Yes. Now come down to the interfaces. Very, very important. Now, in embedded system, it is very, very important to interact to the external world. Very, very important. So for that, we are using a number of communication interfaces. For example, we have serial communications. For serial communications, we are using what? We are using RS-232 and RS-485. Next, we have synchronous serial communications, or I can say in a communications where I am using a clock signal, I will say. So for that, I am using SPI and I2C. Yes, also we have universal serial bus. You can example see in this, what is the example of USB, you can see we are using these particular devices. Also, these particular devices come under embedded system. This is the RS-485 and RS-232, you can see. These are used to communicate with the other peripherals. And this is the JTAG connection pins, you can see. Okay, so these are some communication interfaces which we need to work our embedded system. Yes, also we are using this particular networks. Ethernet we are using also. Yes, for automotive, this is very, very important. I will come down. CAN is very, very important. Next, yes. Now the major question arises that which is the best suited? Yes, so in embedded system now, right now we are using microcontroller, right? So if we are using any microcontroller, so what are the points, or I will say what are the factors on which I am choosing my microcontroller? So there are many factors. Okay, first of all, ask what is my project. I have to analyze which type of project I am doing. For example, if I am doing, so here, if for example, I am taking, so in example 1, I want to glow some LED. So here, this is only I want. So this is example 1. And second, I want to, yes, I want to operate ECU of vehicle. Remember this. So there is a high contrast here in terms of functioning. So if you want to glow some LEDs, yes, I can manage that with the help of an 8-bit microcontroller, right? But if I want to operate a ECU or electronic control unit, then obviously I want a microcontroller of higher end, or any microcontroller which has some good specification, right? So it is very, very essential. So it depends on your projects, or I will say on your on your projects, which type of projects you are doing, whether you need some internet capabilities also, internet capabilities or not. So for internet capabilities also, we will use some microcontroller which have some Wi-Fi and BLE capabilities, right? So it totally depends on your project, which type of microcontroller you use. So a small project, then yes, you can manage with 8-bit microcontroller. But yes, if you're doing a higher end application or a higher project or bigger project, then you can go for the higher microcontroller. Okay. Yes. Always also we will see what is the efficiency. We have to see the efficiency and power dissipations. Okay. So if I want that my project should be efficient one and power dissipation should be less, on that context also I have to see many things. Okay. So whether my microcontroller has that particular capabilities or not, that also I have to see. Okay. So there are many factors on which, but yes, there is always a trade-off between efficiency and power. So on these things also we have to see which type of microcontroller we have to use for our project. Okay. Yes. Now these are some examples of 8-bit microcontroller you can see. So yes, so you can see this 8-bit means 1 byte data. 1 byte data I can send in my data bus. Data bus. So this is Arduino, mostly used by maximum. This is 8 mega 8. You can see this. This is PIC You can see this. So these are some examples you can see of common examples of 8-bit microcontroller. Okay. Now next. Yes. Now these are some examples of 32-bit microcontroller we have. So this is microcontroller from STM. This is from Renaissance. Yes. So this is from Infineon, and this is from Texas. So these are some examples of 32-bit microcontroller. Okay. So we have STM. So there are many vendors which provides 32-bit microcontroller. So I have Renaissance, STM, Infineon Tricore, Texas Instrument. So these are some common examples of 32-bit microcontroller, right? Yes. Now, to write a code or to use this particular, what I will say, 32-bit microcontroller, which type of ID we are using. For example, if we are working with STM32, right? So if you are working with this particular microcontroller, this is a 32-bit microcontroller. So to write any code for this particular application, I need a particular ID. So what do you mean by ID? ID means integrated development environment. Yes. So yes, if you want to work with STM32, yes, I can use this STM32 QID and I can write a code in this. Those who are my students, they know how to write and all this thing. Okay, they have already acquainted with this particular thing. Yes. So in our curriculum also, we have developed a course on this STM32 where you can explore all these things. Means how to. So we have started how to use different type of peripherals. So we are using, for example, Bluepill STM32F103C86. Also, we can work with other development boards also, F407G Discovery board, also Nucleo boards. So yes, so if you are enrolling with us, yes, you will be able to work on this and how STM32 and different types of 32-bit microcontroller is working. You can get a note of that. Yes. Now, so what are the other? For example, if I want to work with Renaissance, yes, I can use E2 Studio. For NXP, I can use Design Studio. For Infineon, Oryx Development Studio is there. So these are predefined, I will say. IDEs are given by particular vendors where you can write your code. You can debug your code, anything you can do, right? But yes, nowadays, a common IDE is used for automotive applications. And for this is the common IDE is IAR. So even if you are using microcontroller of different companies, for example, if you are using microcontroller of different vendors, still with this particular IAR, you can use any type of microcontroller. Okay, and it is a little bit expensive. So yes, with the help of this IAR, you can use any type of microcontroller. And for 8 mega and PIC, you are using MPLAB X IDE. So this IDE is very, very important to write a code, and yes, and then to check how your embedded system is working or behaving, right? So yes, now we will come down and we will see what are the different types of protocols. Very, very important. Okay, for this embedded system. In embedded system, we use different and variety of protocols we use. So one of the protocols is SPI. SPI means, what is the full form of this SPI? This is Serial Peripheral Interface. So here, if you are using SPI, so what are the properties of SPI? You can see this. So it offers high speed. Yes, it is synchronous because clock signal is used here. Clock signal is used. Yes. So you can see what are the other functions. Improved performance is there if you are using SPI, increase efficiency and enhanced compatibility. Yes. So on which particular things I am using? What are the examples where I am using this SPI? Yes. So whenever I am working with a sensor with EEPROM, yes, basically I use SPI. Okay. Next, I have I2C then. Yes. I2C means, what is the meaning of this I2C? It is inter-integrated circuit. So this is the name of this particular protocol, inter-integrated circuit. So what are the properties here? Yes, it is suitable for low speed. Remember this, low speed, short range communication between integrated circuits. Yes, you can see now. So what are the other things here? Why we use I2C? Yes, for example, if you have a low pin count, we have a microcontroller where it has low pins. It has constants regarding the pin. So at that particular situation, yes, I can use I2C. Yes, it has low speed communications for short range connectivity and for simplicity. Yes, for these particular regions, we are using I2C. And yes, it totally depends on the developer or designer where to use I2C or where to use SPI or where to use any other communication protocols, right? So first of all, we have seen SPI. So where it is used, SPI where it is used, basically for sensor, CVPROM. Yes, and I2C. This is what are the different properties of I2C we have seen. Then yes, now this is one of the, I will say, important slide of this particular webinar. Now what do you mean by CAN and why CAN is used for our embedded system, which is very, very important. Now CAN means controller area network, and it is widely used for automotive. So you can, this is controller area network widely used for automotive and industrial. Yes. Now I will also give the point why we are using CAN. It has robust communication. Yes, real-time capability is there and harsh environmental adaptability. Now, what are the other features? Why we are using CAN? Yes, it has inherent properties like error detection. Let me write here. Error detection and error confinement. Yes. So these are one of the, these are two prominent reasons. So it has inherent capabilities of error detection. Yes, they can, if you're using CAN and CAN bus, many things as there, okay. So you can detect the error. Error also, it has capabilities like confinement also. It can confine the errors. So basically we are using CAN in automotive, maximum we are using. So there are two types of CAN. We have standard and we have extended CAN. And yes, we have different data frames for there. We will study all these things, right? So yes, so I have CAN, and then I have UART. So what do you mean by UART? Now UART means universal asynchronous receiver transmitter. Now what do you mean by asynchronous means? I'm not using clock signals here. I'm not using clock signal. Not using clock signal here. Okay. Yes. So for this also we are using, yes, we are using for when you are, what I will suppose, what are the features of this UART? Simple to use. It is asynchronous, and yes, serial data transfer. We are using this UART. Okay. So our main motive is to know what are the different types of protocols which are used in this embedded system. So in this embedded system, we are using SPI, I2C, CAN, UART. So these are some, what I will say, protocols which are used in embedded system, right? Now we will see, now we will come down to the usage. Okay, now these are the main next 5 to 6 slides. So what are the applications of embedded system in this particular, yes, in EV. Now we will see this. Yes, embedded system, there is a variety of what I will say, usage of embedded system in EV. Yes, it is used in battery, or I will say battery management system, also used for the motor, also used for your, yes, everywhere you will find the embedded system. Also it is used for VCU, vehicle control unit, used in electronic control unit, ECU. It is used for your window operations, for your wiper operation, for your operation of your steering, for operation of airbag. So everywhere you will find now that embedded system is used in your EV. So we have taken some examples here. Yes, in a BMS system, I will explain this particular circuit here, but let us see. Okay, so in BMS, we know that what are the functions of BMS, battery management system, and I know that, okay, maximum of you have knowledge regarding this. So what the functions of BMS, what it does. So it basically monitors voltage, temperature, state of charge, you can see. Okay, ensure safe charging and discharging, protects battery from under voltage and over voltage, right? So these things I know that many of you guys have know, but main thing is that how we are implementing, or I will say how this particular we are implementing microcontroller to control this particular system, right? So let me explain this thing. So we have, you can see this. I have a circuit here. Here you can see this is my battery pack. You can see this. Yes, this is my battery pack. Yes, so it is delivering some voltage, some amount of voltage. Here I have cell management. For cell management, I have some chip here. Okay, but before that, you can see this is my microcontroller. You can see this. So this is a So this particular thing I have taken from this STM side. So this is a microcontroller. You can see. So this is SPC57. So this is the brain of this particular circuit. Now let us see what it doing, right? So it is connected to, you can see this, it is connected to the cell management. So I have for cell management, some chips are there. These are my battery packs. In my battery packs, what is the function of the cell management or this L9963E is doing? So it is sensing voltage, temperature and current. Remember this. So that, for example, this particular chip has capability to sense or to take the data of various sensors which are connected with this. Okay, this particular data is sent to this microcontroller. And again, I am saying which type of data is here. So whatever signals we are getting from this battery pack for voltage, current or temperature, all these are analog signal. These analog signals are processed in microcontroller unit. And which particular unit is responsible for this? This is your ADC unit, analog to digital conversion. So this particular unit responsible for this processing of your analog signals. So yes, now this particular microcontroller is processing these things and it is providing those data to the BMS main controller. Now one thing, now in terms of connectivity, again, I have said that, okay, we are using different types of protocols. Again, we have used CAN here. And yes, for power management, I have a module for this power management. And yes, again, we have seen what are the different types of memory units we are using. For example, we have using flash, RAM, ROM, EEPROM. EEPROM is used to store non-volatile data. Remember this, non-volatile data. Right, non-volatile data. Okay, non-volatile data. Okay, so here you can see what is the function of this particular microcontroller unit. Yes, I can consider this is an ECU, electronic control unit, where it is monitoring the temperature, current, voltage of a battery pack and communicating with the main BMS control with the help of CAN. I have a power management module and EEPROM connected to this particular to this particular ECU. Why EEPROM is used? It is to store non-volatile data, right? Yes, and then the cell management is done by the help of this particular chip, L9963E. This L9963 is sending data to the microcontroller, okay, whatever it is receiving from the battery pack. So this is one of the overview, how I can say that how a microcontroller is used in ECU and how it is actually, it is just a generic circuit. Many complex circuit is there, okay, for this embedded system and how these things are, this takes place, okay. So the complex circuit is there. Okay, this is just a generic one. Yes, so now you can see what in motor control. Yes, in motor control, why we are using motor control. So electric for this motor control, we are using again a microcontroller. Okay, so we are controlling different types of motors. We have BLDC, PMSM, and yes, now how we are controlling motor, again with the help of this pulse width modulation and different other techniques are there. But yes, to control these motors, the main thing is this. We are using one, again, a microcontroller unit. So this is the main contention is this one. Okay, again, I'm using a microcontroller. So I can consider this is a ECU. Let me write here. So in this ECU, I'm using a microcontroller. So this is my motor. Yes, I have different type of sensors. You can see this current sensing, overcurrent protection, speed sensing sensors are there. All these sensors are giving what I will say signals to this or sending signals to this particular unit. Okay. So here I have different. Now you can see this. I have a DAC.
Sir,
Yes.
sir, your uh, PC is not showing, sir. What you tell us.
Sir, your presentation is not show.
Okay,
Sir,
okay.
sharing
Screen
is
is
not.
visible, sir.
Another person is sharing the screen.
No.
Okay,
Not
okay.
visible.
Let me do that. Okay, okay.
Sir, Vinod is showing.
Now it is showing.
Is
Yes.
Sir, screen is visible. No issue. No any issue, sir.
Yes.
Yes,
sir,
visible.
is visible. Or
Okay.
visible.
It's not visible.
yes, sir, is visible.
Yeah. Okay. Yes. Yes. Now we are witnessing a circuit here, which is controlling the motor. Okay. Yes. So in this motor controlling circuit also we are using. That means in brief, if I will explain. Yes, in motor control circuit also we are using microcontroller. You can see this. This is my microcontroller unit. This particular unit which I have surrounded like this. So here, what is doing? So I have driver here. So you have driver here, and this is a what I will say. Let me. Yes, we have different using. You can see this. Yes. So I'm using different types of sensor here. All sensor signals are going to this particular unit. So here I have this one. Okay. Analog input protection. You can see, but yes, I have ADC module is there. Okay. And there I have the drivers here, and this is the inverter circuit. Remember this. Okay. What is the function of this inverter circuit? It is converting DC to AC. Remember this. And these are my gate ICs or MOSFET, I will say. So yes, just see in this circuit, it is not to means what I will say, it not to make it complex. Simple, you can see this. Yes, just from this slide, I just want to say that yes, in your motor control also you are using microcontroller, or I can say you are using a ECU, and this particular microcontroller is using what I will say is protecting your yes, it is protecting your motor from various things, and it is also getting what I will say various values from various things. For example, yes, many sensors are integrated. Yes, it is receiving sensor values from different type of sensor. For example, yes, from this temperature sensor, current sensor, over voltage sensor. Yes, and this is all just a circuit here. Okay, so my main thing is that yes, in this particular circuit also we are using microcontroller, right? Yes. Now come down to the power electronics part. So in power electronics control, we are using various types of modules, or I can say circuit, right? We use inverters. Yes. Inverter, what is the function of inverter? It will convert DC to AC. We are using DC-DC converters, onboard chargers. Yes. In these also we are using microcontroller. Okay. Remember this particular thing. So for my power electronics control also, we are using various types of ECUs, and one ECU can be dedicated for inverter and for onboard chargers. So here also we are using microcontrollers, right? Yes. Now come down to the another major topic here. One, what is VCU? Okay. Okay. So what do you mean by VCU? See, this is actually a vehicle control unit. Very, very important. Remember this. Now you can imagine the extent, what extent this particular means why embedded is necessary. Remember one thing. I can have more than 70 ECU. So in one particular EV, normally I have more than 70 ECU is there. ECU is what? Electronic.
70 different controllers.
Yes. Controllers, I'm saying about ECUs. Okay. So there in ECU, I'm using a microcontroller, right? So whoever is asking, don't worry, I will take the doubts. Okay, let me complete this and then I will take your doubt. Okay. Yes. Then I have electronic control unit. So this particular units, if I have more than 70, it can be more than 100, right? If I have a high-end car, it can be more than 100, right? So if this particular 70 ECU, they will communicate to one VCU. Remember this. So this is one VCU, vehicle control unit. So this is one of the, we can say, the master brain of your EV. So let us see how it is communicating. Now you can see this. In your left hand side, you can see, yes, my VCU is communicating with other ECUs with the help of what? Yes, we have different types of, with the help of protocols, we can say, with the help of CAN. So this VCU is also integrating with different type of microcontrollers and also BMS and other things. And how it is communicating with the help of different types of protocols. These are the protocols by which VCU is communicating with other ECUs. Okay. And yes, this VCU is, again, this is a high-end microcontroller. Okay. So it has some power necessities. It has some processing unit. It has some storage. And yes, some digital input is there. Analog input is there. I know we already know what in digital analog input, what we are taking. For example, we are taking some, if I'm taking some inputs from sensors. Yes. Then we are using ADC here and processing those data, right? Yes. And yes, if we want to, for example, if I want to send my VCU data to another particular device or any embedded system, I can use external communications here. So in external communication, what I'm using, so with the help of Wi-Fi, I can send this data, or I can, with the help of, if short distance, I can use BLE or Bluetooth. But if I want to send to long distance, I can use Wi-Fi. So this is, again, I can say that. So you can imagine how embedded system is used in your EV. It is, I will say, everywhere. You just touch, you will find that your embedded system is used in EV. Okay, starting from your electronic control unit to VCU to BMS to the motor control part to everywhere you can find. Okay, yes. So this is another example. Nowadays, it is very, very, what I will say, very, very famous. What do you mean by ADAS system? Okay, so I know that, okay, many of you know what I mean by ADAS system. It is Advanced Driver Assistance System. In this particular system also, we are using microcontroller. Remember this. So we in microcontrollers, and yes, in some high-end ADAS system, we are using microprocessor also. Okay, let me be very clear. So what are the components which are using in this particular system? Yes, we are using radar, LiDAR, camera, ultrasonic sensors. And yes, how we are controlling all these things? Yes, we are controlling with the help of a microcontroller. Okay, now you can see this. Yes, so we are using LiDAR, radar, and all this programming. Yes, we have to do in the microcontroller. Okay, but yes, for the high-end ADAS system, we are using microprocessor, right? Yes. So now at last, okay. So this is my this is our embedded kit, which is exclusively developed by DIYguru in partnership with EVI technology. Yes, so this is our, I will say, first step where we just we have implemented this particular kit, or we have developed this kit so that our student will benefit it. So in this particular kit, we have actually simulated a EV environment. So you can say that how EV environment. Yes, you can see this is my display segment. For display, I can use, this is my LCD. Yes, this is one of the microcontroller, main microcontroller. Let me write here. And this is my, yes, I'm saying that microcontroller. Okay, second microcontroller. Microcontroller. Yes. So what I'm doing here, I'm communicating with this particular microcontroller with the help of CAN. So I have used, what are the different types of, yes, I have used all types of protocols here. So in this particular kit, we have emulated, we have, yes, EV environment we have simulated. So in this, we have different types of LCD, display units. For example, we have LCD, I have OLED, I'm communicating with the help of CAN. So these are actually STM based microcontrollers there. So we are using those particular things. The name you can see, STM32F103CLT6. And here also we are using other, what I will say, other protocols also. For example, for implementing this particular sensor, this is my accelerometer and gyroscope. So for this, I have used this I2C. Okay, this is my EEPROM. These are my CAN transceiver. You can see. So this is my CAN transceiver, one transceiver for this one, and another for this one for this. Okay. Now you come down to this part. This part is very, very important. So here you can see I have a battery. I can get my battery current, voltage, charge, anything in this particular display. Yes, I have given some load. So in this particular load, I can increase my current voltage. We can see this particular thing also, how if I'm increasing my load, if in a charging discharging time, what is my load, what is my voltage, those things we can see in this LCD, also in this OLED. Now this is the main part. This is my charging discharging module. Okay. Now this is my microcontroller. You can see this is OLED. Yes. Here you can say this is a Bluetooth module. We will be able to send anything regard how to send in Bluetooth. That also we have implemented here. But here we have implemented this Bluetooth module with the help of UART. So yes, in nutshell, we have used all protocols here: I2C, SPI, CAN, and UART. Okay.
Sir, your presentation is not visible.
Again, not visible. Okay, good. Just wait.
Visible, sir.
Just wait a minute.
No,
Just-
sir.
Okay.
Now visible.
Yes, now visible. Okay. Yes. So, so this is my BMS model. You can say simulation of BMS model where I have. So we have implemented one battery here. You can see how my battery is charged, discharged. So this is my charging discharging module here. You can see. So this we have given some load here. So this particular display, whatever we have taken in my load, how if I'm increasing the load, for example, if I'm making it on this particular switch or making this particular switch on and this particular switch on, how I'm just changing my load, that also we can see in this particular LCD. And yes, some data we can see in OLED. We have implemented other peripherals also. For example, we have some relay, some RTC cell. Why we have used this? This is for real-time clock, right? So yes, so these are my DB9 connectors which are used with the help of UART protocol. So yes, so in this particular kit, I have simulated EV environment here, successfully simulated EV environment. So I have used different types of protocols here in this particular kit. I have used SPI, I2C, CAN, which is very, very important. Yes, I have used this. So in this particular kit, I have shown how to communicate with the help of CAN between these two microcontrollers, right? So this is a nutshell regarding the kit. Yes, in the upcoming, those who are attending my class. So right now I think we are studying C. Then after C, we will go for the STM32. We will see basics and peripherals. Then at last, I will teach how to approach this particular kit. Okay. So this is all about.
Sir, what will the cost of this kit?
Kit, I think my management team will inform you, or my sales team will inform you regarding this. Okay. So this is all regarding this. Just tell me, okay, if you have any doubt, now the floor is open. You can ask.
Yes, sir. What are the projects we can do in embedded system,
See,
which will look good in our resumes?
Okay, so Amit, you are a student or you're outside of
I'm working.
So you're working and you are student of DIYguru or you are?
Yes.
Okay, you're okay. Okay, Amit.
I'm currently enrolled.
Yes. Amit, whatever we will do with the help of this kit, okay, again, you can show in this project. So these are real-time industrial projects, right? These are not easy and nowhere you will find all these things. Remember this. And yes.
Can you name, sir, 2-3 projects?
Yes,
which are
in this, whatever projects we will do in this kit, that is, I will say, very high end. But before that also, we should know how to work with, yes, 2-3 projects you are saying, we will do many projects with the help of this kit. Okay, for example, 1 or 2 projects, if I'm saying how to communicate with the help of CAN protocol, that is very, very important. Means we are communicating with the help of 2 nodes. Okay, then how to get the data of this particular battery and sensors, and how to display all these things in our LCD or OLED. That is another. Okay, again, how to control my charging discharging in a battery. This is another project. So yes, I have list of projects as there, which will be done with the help of this particular kit. But before that, Amit, okay, we will do many projects regarding how to use a peripherals, what is the embedded system, and then we will do all these things. Okay, we will start from the scratch, and we will start from the LED, then LCD, then we will move to the other protocols, and then at last we will come down to the kit. Yes. Any other question?
Okay, sir.
Yes.
What is the particular model number of that STM chip?
It is actually estimated to F103C8T6. Okay. So Amit, actually we are not only we are doing with that particular, we are doing many things. Okay. If you attend my workshop, in my workshop also, yes, you will get the hands-on maximum things we will do with the help of this kit. Also, I will give how to, also we will know how to work on other boards also. Okay. That provision also I will provide. If you will attend my workshop, also you will, if you will attend my classes also. Okay. In class
So,
also
sir,
we
how
will
to
see.
join your workshops? Like now I'm currently enrolled in DIY. So how
Okay.
I can?
I think recently I will be doing a workshop in Pune and Mumbai, I think. Okay. So I think in community there will be a declaration regarding any workshop.
Yes, but
Immediately you
I'm
can
in
join.
Delhi.
Yes. Okay. Yes. Anyone?
Sir, what are the prerequisites?
Okay. Just one person. Yes. Yes, Miss Elo.
Okay, I just wanted to find out when you were explaining I2C,
Okay.
I'll just repeat the question I put in the chat. When you were explaining I2C, you mentioned something about low speed communication. So
Okay.
my question is, why low speed communication when we want high speed communication? Where is low
Okay.
speed communication?
No. See. So yes. So for high speed, you can see we have different types of protocols. Okay. For example, Miselo, if I want high speed, I have different many constants here also. So for example, if I'm using, if I want to communicate in a short distance, I can use SPI, but SPI needs 4 wires. If I will use SPI, then I have to use 4 pins also. But if, for example, I have a constant of pins, then at that particular situation, I can use I2C, correct? So I2C, yes, I know, for example, if I want to communicate with a peripheral, but yes, if that peripheral can send data in a low speed, that is manageable for me. At that situation, I will use I2C. And I know that in I2C, I have to use only 2 wires or 2 pins for 2 pins. So there are many considerations, okay, for which I can use any protocols. So to decide which type of protocols and all, so actually before starting a project or an industrial project, we have means someone has to sit for 2 or 3 months deciding which peripherals you have to take, which protocols you have to take, how to design that, also what are the control parameters you need. So these things you have to take into consideration, right? I hope your doubt is clear, Mr.
Yeah, thank you.
Yes. Okay, thanks. Yes. Next.
Yes, sir.
Okay, Karthik. Yes, Karthik.
Sir, what are the prerequisites for embedded system?
Yes, Karthik. What are the prerequisites? Actually, yes, if you want to enroll in this particular course, most welcome. And also I will say that C, you must know some parts of C. And after that, C, yes, C++ is needed, but not that much. But because see, I am there, so don't worry. So what I will say, after 4 or 5 or 6 years of experience, then you can go for Linux and Python. But that is, again, I will say for after your 4 and 5 years of experience, I will say. But for the starting, I think it is better you can start with C. So first of all, you work for 2-3 years, then you can move from C++ or anything, any other language. Yes.
Thank you, sir.
Sir, is there any simulation software for that, like where we
Yes.
can simulate
Yes,
this?
Amit. You can do all this simulation with the help of Proteus also. You can use Proteus also, but I will say that, okay, because I am a person, okay, who doesn't believe in that much, okay, better you do all your projects in the hardware. Why simulation? Yes, to some extent, if you want your simulation, you can do in the Proteus. I will explain that, because if somebody will ask that in industry that, okay, yes, you know how to also work in the hardware, also you must know how to work in the Proteus also. That also we will study, okay, that is not a big deal, okay. That we study in our curriculum also. Proteus has been added, and yes, other parties also there. Yes, next.
Sir, different types of controller and where it is used, you show the different types of kit.
Yes. See. Different. Yes. Sapna, actually, in our EV, we have different things, right? Different systems. We have motor controller, we have BMS, we have, for example, if you are operating the window, if you're operating the what I will say, wiper. So all this for example, for all this one type of microcontroller I cannot use. For example, nowadays, this NXP SK32 something series name, it is used for motor controlling. One Infineon tricore microcontroller there, it is famous, and maximum vendors they use for this BMS. So there are many considerations for which a company takes that, okay, for this particular thing, I will take this microcontroller, or the what will the efficiency of this microcontroller. One, there are many considerations for that. And again, I will say, it is based on a project, or yes, based on your project, on which I will decide which type of microcontroller you use. I have already said that if I want to glow a simple LED, on that case, I can use my 8-bit microcontroller, right? I don't need any higher end microcontroller. But yes, if I want to do anything more specific, anything related to high end, then I can go for 32-bit microcontroller or any higher end microcontroller. I hope the point is clear. Tapna.
Sir, I mean there you shows the different and where it is used. Means you tell me, मतलब आपने बताया तो
बताएं कोई दिक्कत नहीं होगी, बताएं कोई हिंदी बताएं कोई दिक्कत नहीं होगी. Here we are here to share the knowledge, right? Yes.
Yes, sir, I can speak in English language.
हाँ कोई नहीं, हिंदी
Sir, different types of
microcontroller, right? मैं वही तो बोला. Okay.
Yes,
Yes.
sir. Yes, sir.
Yes,
But I don't get your, मतलब मुझे जो आंसर चाहिए था वो आपने नहीं दिया.
कौन सा नहीं दिया, बताएं तो सही, आपका डाउट क्या है?
हाँ सर. सर जो आपने ऐसे सर्किट दिखाए थे, मतलब डिफरेंट टाइप्स ऑफ माइक्रोकंट्रोलर्स एंड देयर नेम्स आर डिफरेंट.
हाँ, मैं फिर से शेयर कर रहा हूँ एक बार, कोई नहीं, मैं फिर से दिखा रहा हूँ आपको. ठीक है, मैं फिर से दिखा रहा हूँ आपको, कोई दिक्कत नहीं. एक मिनट
सर, आप वो स्क्रोलर यूज करके स्क्रॉल कीजिए.
यस, ओके, नाउ इट इज सीन. ये आप बता रहे थे ना,
STM and other Arduino like and other things here we use. Then which type of circuit where we use?
अच्छा, सर्किट इसमें see these are dependent on the projects. ये तो इंडिविजुअल के ऊपर है ना, वो क्या चाह रहे हैं. If someone is compatible with Arduino,
यही चाहिए था सर,
Yes,
मतलब
yes.
जो
If-
स्पेसिफिक है तो वो कहाँ पर यूज करते हैं, मतलब जो है.
yes, see, Sapna, it is totally depend on the individuals. It is totally depend on the person who is acquainted. If someone is acquainted with Arduino IDE, or he is means compatible with Arduino, he will use a Arduino. If somebody who is compatible with bare metal programming or register-based programming, he will do the ART8 mega or the microchip. Again, he will consider in the project. So whether my project will be cost effective or not. If I want that, if a simple usage, my usage is, for example, I want to use, or I want to glow LED. For that, I will use this type of microcontroller, right? And as a person, if I don't know how to work with Arduino, whether I will use that? No, I will not use that. Also, in a company, there were many considerations where I have to take consideration with power constants, the pins constant, what are the peripherals I need to work. So on these constants, I will decide which type of microcontroller I will use. I hope the point is clear.
Sir, one more thing to add with Sapna ma'am.
Yes.
Can you show me the microcontrollers once again?
So this one, right?
Next one.
Okay, next one. Yes.
Next slide.
So,
This type of circuit.
So, adding to Sapna ma'am, what will be the easiest microcontroller to use? It is Arduino, right?
Yes. But remember, see, this Arduino is not used in industry, right? Arduino is used for your school-based projects or your university-based project. But it is better. See, it is better if you are starting with Arduino. It is better because you know how to work with different peripherals, right? Okay. And then you can go for register-based programming or this simple 8-bit programming, and then you can come down to this 32-bit microcontroller. Okay.
Okay. And
yes,
mostly we use STM32 in our EV vehicles.
Yes. No. In EV vehicles, there are many ECUs, right? Electronic control unit. Yes, so for example, if I'm motor controlling, I'm using this particular, there is a team of members which are working in all development. So for one particular team, I think in that team, 4 or 5, it is not like that one person is working. If it is an OEM, might remember one thing, okay, in motor control, there will be 4 to 5 members, and they might be working on this NXP controller. If someone is working in this door and wiper, they might be using this STM. If someone is using working in this BMS part, they might be using Infineon Tricore. So these are some, what I will say, uses of different types of microcontroller. Okay, yes.
So, sir, so
but
these are all
in
are
this
real
course
world
we are
controllers, like
Yes,
learning
yes,
used
with
in
these are
real
all
world.
real world
STM32.
microcontrollers, right? Yes. And yes, in our curriculum, remember this, one of the important microcontroller is just STM. And we are, means I have developed that curriculum. And yes, you will get to know how to work this STM. In STM also, you will work with different types of boards. For example, if I'm saying your STM32, whatever board, blue pill we are using, that particular chip which are using in the kitty, that is blue pill, STM32 F103C86. Okay. Not only that, also we will get to know to work on different boards. In STM, we have different boards like F407G board and nuclear board. Yes, that also you will get, right? Yes. Any doubt?
सर हम अगर इनिशियली एंटर कर रहे हैं इस फील्ड में
One, Praveen, just a minute. Darshan. Yes, Darshan. Yes, Darshan.
हाँ सर
Praveen,
अगर
just
हम
give me 1
इनिशियली
minute. Okay,
एंटर कर
Darshan.
रहे
Yes,
हैं
Darshan.
ओके सर अगर हम इनिशियली एंटर कर रहे हैं इस फील्ड में तो
हाँ
अगर हमें सिर्फ ऑटोमोटिव फील्ड में ही आगे बढ़ना है इसमें तो हम
हाँ हाँ
8051 या पिक से स्टार्ट कर सकते हैं
Yes, yes, excellent. Okay, you can start with
ओके
PIC or you can start with any 8-bit microcontroller. It can be your PIC, it can be your 8 mega, or it can be your 8051. But remember, it is better if you are going for register-based programming, or I will say that bare metal programming. Okay, directly you are accessing the registers. Okay. Yes.
Okay.
Next, Praveen. Yes, Praveen.
Sir.
Sridhar, just give me 1 minute. Okay.
Okay.
Next question, you. Praveen. Yes, Praveen. You are asking something. Yes. Praveen. Praveen, I'm not audible. Yes, Praveen. Again, just speak out. Praveen.
Sir, STM microcontroller is microcontroller.
Okay, Praveen, I will take your question. Okay, you are not audible. Okay. कोई नहीं, मैं लेता हूँ. Sridhar, yes, Sridhar. Yes.
Sir, can we use one can for 3 or means 2 or more ECU?
Yes, why not? Okay, CAN is there. Okay, because we have different ECUs are basically nodes, and yes, in that with the help of CANs we can use maximum peripherals, or ECUs we can communicate with the help of this CAN. For that reason, CAN is used. CAN, why we are using CANs? Because yes, it has inherent capabilities. We can add nodes, and what are the inherent capabilities there? We have error detection, error confinement, many other things are there. Okay. Yes, for all these reasons, we are using CAN in EV. Yes.
Okay. It's mean 70 ECUs in one vehicle. Then there is only one CAN, right?
No. See, it is not like that. Okay, we have to see whether there is. We need the communication between 70 or not. If there is a necessity of communication between 70, yes, we can do. But if there is no necessity to communicate all 70 ECUs, don't you think it is irrelevant to communicate all 72 ECU? If there is a necessity of 1 or 2 ECU or 5 ECU, 10 ECU, then as per that we have CAN. Okay, and then all they can be communicated to the master VCU, right? You got the point?
Yes.
Yes. Okay. Yes, others.
Sir,
Yes,
I have a
others.
question like this course is specially designed for an embedded system or an electric vehicle. Like at present, I am not enrolling in this course, but I want to enroll for the course, and I'm working in electronics company.
Okay.
I want to do a course, but I want do like a course for embedded system. So this course is especially targeting embedded system or electric vehicle.
Is it targeting
I'm little bit confused.
both are this? Okay. Yes, I got the point. We are targeting both. So here we are not only, first of all, before moving to EV, if you don't know how to work on different peripherals, if you don't know how to work with microcontrollers, if you don't know how to work with ID, then how we will move to this particular EV? Yes, we are targeting both the things. We are doing the embedded things, and yes, then at last we are doing the application-based things, okay, or with the higher end things of the embedded, which are related to the EV. And this with the particular with the kit, we are doing all these things: battery simulations, display and all. Also in peripheral, so we will do LCD and all. Else before that also we will study the protocols and all. So these things we are doing. Both things we are doing others.
Okay, so like we are also learning embedded from basics.
Yes,
not like
yes.
we are learning embedded so fast, then we come to the like especially for
No. That's
is
okay.
designed for embedded electric vehicle like.
No. Others, we in DIYguru we have a proper hand holding, and we will start from basic 8-bit microcontroller. Also, we have curriculum regarding Arduino 8051. Then you can move to STM32. Okay, STM32, I'm looking after STM32. And then you can, if you're moving to STM32, in STM32, you will learn many things. Okay, so that's the point as others. Any other, any other question?
Can you explain me, sir, the EEPROM, sir, once? EEPROM, it told like this non-volunteer data. Can you explain and where it will be used? And can high and can low, I want to know, sir. Can it?
So here I have not mentioned can high and can low. Where I have mentioned. So,
no, I just asked you.
Okay, so don't worry. Okay, Satish. Okay, it is better. You can.
I am not from the electronic background.
Okay, yes. So I will. Don't worry. Okay. So things are there. So yes, EEPROM is used to store the non-volatile data, right? And can high, can low are these are yes, these are two lines which are used to communicate with the other peripherals which are used. Okay. So what other things you want to need?
This EEPROM, what are they using 24X and 25? Can you explain, sir, that what is type of EEPROM ICs we are using here in EVs?
I have already explained right now. Yes. So here I have, okay, EEPROM is there. It is used to store the non-volatile data. That means if my power goes off, still my data will be stored in my EEPROM, right? Now, what are the different ICs I have? You can see this is my controller here, and this is my charging discharging module is there. And other thing what I am using, this is my CAN transceiver. This is my CAN transceiver. You can see this is my I'm just moving my cursor here. And this is my TMP280 sensor is there. This particular temperature sensor is there. Temperature humidity sensor is there. And this one is MPU 6050. This is for accelerometer gyroscope. This is my display unit. And these are my things. Okay. What are the doubts I have? And who has asked this? Satish, I think. Yes, Satish.
Okay.
Okay. Yes. Any other doubt?
Sir, this is Tilak from September 24 बैच.
No issue. Yes.
जैसे मैं आपको बताना चाहता हूँ सर, मैं 10th पास किया हुआ ITI इलेक्ट्रॉनिक मैकेनिक कैंडिडेट हूँ और नैनो डिग्री के लिए एनरोल किया और सब कोर्सेज मुझे अटेंड किए गए. LMS भी है मेरे साथ. तो इसके साथ जो एसेशन हमारा चल रहा है, एक बार ये कंप्लीट होते हैं एम्बेडेड और आपने जैसे बताया सर SPL 32, ये दो सॉफ्टवेयर आप हमको सिखाएंगे, करेक्ट है सर? तो इसके ऊपर मैं ये जानना चाहता हूँ कि मैं सॉफ्टवेयर में इंटरेस्ट रखता हूँ, टेक्नोलॉजी भी मुझे आगे मतलब पहले जब से मैं छोटा हूँ सर तब से मुझे इसमें इंटरेस्ट है, बट मैं कभी सॉफ्टवेयर में भी नहीं गया हूँ. मतलब मुझे ये बेनिफिट भी उतना ही होगा ना अगर मैं ईवी इंडस्ट्री में उतरता हूँ तो?
Means you are asking regarding, okay, Tilak, you are asking regarding whether if you will do this STM32 course, whether it will be beneficial or not.
Sir.
Yes, it will be highly beneficial for you because
yes.
See, yes, it will be highly beneficial for you. Okay, so if you are enrolling in this, or if you are already a student, okay, yes, it will be highly beneficial for you. Okay, because if you know all these things, because nowadays embedded system is high in demand, right? Because now our EV is also sensor based. So now we see that okay, many sensors we are integrating, temperature, voltage sensor. Yes. So for this, okay, yes, it is highly important. Yes. Okay.
Next. Workshop आप लोग रखोगे, correct?
Yes. Next workshop, Tilak. Okay. Let me see. Tilak, let us restrict the questions to this webinar only. Okay. Yes. Next question from. Okay, guys. So I hope I think now I will give the control to our sales team, Mr. Zisan, and I think he will guide you now. Yes, Zisan.
Sir, Ashutosh.
Okay, everyone. Okay, so it is already 9. Okay, so we will keep it till this. Yes,
I just wanted, it's off this webinar, but I just wanted to ask this. We have this Pune workshop, right, on embedded?
Yes.
So, is it like we have to complete the project for enrolling, or is it okay that if I complete the LMS course and then the project is pending? Because I'm like about to complete the course on LMS.
Serious, I think whatever knowledge I have, I think you have to complete C and some part of your 805 and all. So I think it will depends on our tech team, okay, so whether they will allow and all these things. But because I don't have that much knowledge. What you need to complete and all. Okay, you can ask my tech team. Yeah. Okay.
Okay.
Okay. Okay, guys. So this is a nice meeting with you all, guys. So very good evening and best of luck. Okay. From my side, so this is my humble request. There will be a hand holding regarding STM32, regarding embedded system. I will be always there. Okay. So any problem, any doubt regarding this STM or embedded system, you can definitely approach me. Yes.
Sir, when lecture we start for us that from a related MD data now?
Okay, we will start. We will start. Yes, Devika. This okay. I will take the last question from Devika. Yes, Devika. Yes.
No, sir. No.
Devika, you have. Okay, okay, okay. Then okay. Thanks a lot to all participants. Okay. Good evening. Take care. Goodbye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you so much, sir.
Yeah.
Thank you, sir.
किसी को कोई डाउट तो नहीं है? हेलो
हेलो
हाँ, किसी को कोई डाउट तो नहीं है?
नहीं सर।
ओके, ठीक, लीव कर सकते हो आप लोग। थैंक यू सो मच ज्वाइनिंग के लिए। राज, आपको कोई डाउट तो नहीं है?
नो सर, कोई डाउट नहीं, क्लियर
आप लीव कर सकते हो मीटिंग।
वो लगाने वाला मैं